Okay, in this video we're going to go over Chapter 5, Section 4, using medians and altitudes. So one of the first things you want to ask yourself is, why do they have two topics in this one section? And the reason for that, I believe, is because both of these geometric features begin at a vertex. So with that in mind, so I'm going to say vertex, just so we have this in our mind. Let's begin the notes. So here's some vocabulary to start. The median of a triangle. So a median of a triangle is a segment that runs from the vertex, okay, there's that word, to the midpoint. So on this line, we're going to write midpoint. The midpoint of the opposite side. So I've already put a midpoint on the opposite side from this vertex. So if I were to, let me just try this little tool. If I were to connect it, that would be a median. All right, there are 3 medians in every single triangle. So let's try to do another one. So I'm just going to eyeball from this vertex right here. Okay, I'm going to find the median, or the middle, of this segment right here. So let me try this. I would say perhaps somewhere around there, but on the line. So now I'm going to try this little tool and go from here to about there. Okay, that looks about right. And I'm going to do the same thing to the other side. Now I'm starting at the last vertex. And let's say that that's about where the midpoint's going to hit. I'm going to come from this vertex, and I'm going to go right there, pretty much. And they're going to all meet in the center. So let's call the place they all meet, well, we're going to draw a little arrow to it right here. They all meet here, and that has a special name. That is called the centroid. Okay, it's always going to be in the center of the circle. So the 3 medians, and the median goes from the vertex to the midpoint of the opposite side. All 3 medians will meet in the center of the triangle at a place called the centroid. All right, the other vocab words we're going to talk about is the altitude. So the altitude is the perpendicular. So on this line we're going to put perpendicular segment from the vertex. So again, it's from the vertex to the opposite side, or to the line that contains the opposite side. Alright, so if it's perpendicular, and that's all I know about it, it's perpendicular, I would absolutely need to have that little right angle right there. Okay, now you can draw other perpendicular lines from the other 3 vertices to the sides opposite them. So let's try that with my fancy little tool. So if I'm going to start here and I want to hit the opposite side at a right angle, does that look kind of okay? Possibly. It's hard to do it without measuring. But let's just say that that does form a right angle. Well, just for argument's sake, let me try that again, see if I can get a little bit better. So if I come from here, maybe there. So let's just assume that that's a right angle. We'd have to measure it to know I have it correct, but for our purposes, we're going to assume it's there. Then let's come from this remaining vertex to the other side, and we're going to go on a limb here, and I'm going to tell you that that's a right angle so that I can make the point that all 3 of these altitudes intersect at the orthocenter. So the orthocenter is where they all intersect. All right, now let's play around with some of the theorems that pertain to medians in particular, because they're going to help us do our measurement. So we'll do that on the next page. Okay, here's a very, very important piece of information for us, because this is mainly what we're going to do with medians in this section. So the theorem says that the concurrency of medians of a triangle, the concurrency means that's where they all meet together. We are establishing that that is at this point right here, which is P. That's your concurrency. There's a certain relationship that's happening there. So it says the medians of a triangle intersect at a point that is 2/3, this is huge, 2/3 of the distance from, again, each vertex to the midpoint of the opposite side. Okay, so the medians intersect at a point that is 2/3 of the distance from each vertex. So let's start with B. So from each vertex, then go to the opposite side. Okay, whoops, wrong symbol. Let me get out of there. Okay, let's try to do this one. Okay, I'm coming here, and I'm going to come straight down. That's the whole way to the opposite side. Now let's change color, and let's say from B to, whoops, try that again, from B, okay, I'm starting at B, whoops, I am stopping, start here, oh my gosh, it's going to drive me crazy. Okay, so from B to here, that is 2/3 of the length from B to F, okay? That happens at every single part of the triangle. So let's go over this again. I'm going to take my black one, and I'm going to connect from here to the D. Okay? Where is 2/3 of that length? Change it to the red, and that is from C to, I'm going to get to this P. It's not letting me get there. Maybe I can't do it with this tool. Crazy tool. Okay, we'll do it with just a marker. So from C all the way to P, that length is 2/3 of the distance from C to D. Okay, we've got one more. We're going to try to do the black again. So from A, and it won't do it. So I'm not going to do that one. So let me get out of there. Go back here. We'll do it as black. So from A all the way up to E is the whole piece. That's my median, but we'll change back to red. From A to P is 2/3 of the length of the whole piece from A to E. So that is stated here. All right, so the point of concurrency, that P, is the centroid, and it's good to know that the centroid is located inside the triangle. All right, we have to play with this 2/3 because that's going to be an important item to practice. So we have example 1 and example 2 to do that practicing. All right. Alrighty, so here is example 1. So it says use the point of concurrency. So I'm going to put a little dot on the point of concurrency, so it's right there. Use the point of concurrency of the medians of a triangle. So that means all 3 medians come together there. So in this big triangle, RST, so Q is the concurrency of the medians. Okay, so that little point that I just drew is Q. Okay, so that is point Q. Okay, so if we know that SQ is 8, they want us to find QW and SW. So let me change this to red. So SQ is this little red piece right here. So how is that related, if you remember from the discussion on the previous page? Because we have to set up an equation. Okay, so SQ will be 2/3 of the length of SW. That is what you need to establish first. Now, they told us that SQ is 8, so under SQ, you're going to put an 8. 8 equals 2/3 SW. We don't know what SW is. How will we get it all by itself? What you should do is multiply the SW by the reciprocal of 2/3. That is 3/2. When you do that, the 3's cancel, the 2's cancel, that term becomes a 1. As long as whatever you do on the right side, you do on the left side, you're all set with your algebra. So multiply straight across, okay, straight across, and you get 24/2 equals SW. Okay, put 2 into 24, it goes 12 times. So SW, which is this green big piece, SW is going to be 12. So let me turn that off. This equals 12. Okay, they're also asking us for QW. So what is QW? QW is this remaining little piece right here. So if I know that SQ is 8 plus QW, that has to equal 12. Subtract from both sides, you get QW equals 4. Okay, a pattern you're going to start seeing is this. If you know the measurement from the vertex to the median, to the center, the centroid, whatever that measurement is, if you divide that in half, that will be the remaining piece. So 8 and 4 give me 12. I know that works. Okay, there's one more practice in the next example, so let's do that on my next page. Okay, on this page they're saying in the big triangle, which is HJK, P is the point of concurrency of the medians. That point is called the centroid. So, and they go on to say, and JP is 12. JP goes from the vertex to the centroid. JP is 2/3, by the way, of PT. So they want us to find, of JT. They want us to find PT and JT. We need an equation. We need an equation that depicts a relationship. So I know that JP, that's from the vertex to the centroid, equals a length that is 2/3 of the distance of the median, which is JT. Okay, so I have a value. My value I have is for JP. So under JP, I'm going to put a 12. 12 equals 2/3 JT. To get JT alone, I'm going to multiply it by the reciprocal of 2/3. So I'll change colors. That reciprocal is 3/2. When I do that, the 3's cancel diagonally, the 2's cancel diagonally, which leaves this as a 1. If I multiply by 3/2 on the right, I must do the same on the left. I'm going to show you canceling here. On the diagonal, 2 goes into itself 1 time, 2 goes into 12 6 times, 6 times 3 is 18. 18 is the length of JT. All right, if this whole piece, so right here, from here to here, if this whole thing is 18, and I knew this piece from here to here is 12, then what is this piece from here to here? So we need an equation. Let's get an equation going. If I know that JT, that's going to equal JP plus PT. Plug in numbers. We just solved. We know that JT is 18. 18 equals JP. that's the unknown. I'm going to give that a variable of x, plus pt, which we know was, excuse me, let me backtrack. I think I lost my head. Okay, jp was the number they gave us, which was 12. They would like us to find pt. That's where I'll put the x. You have a one-step problem. Subtract 12 from both sides, subtract 12, you get 6 equals the x, and in this case the x was the pt, which was this piece right down here, right there. Okay, right there. Alright, so does this make sense? Is it reasonable that 12 plus half of 12 is 6, 12 plus 6 equals 18, and I have it all set? Okay, we have homework to do in this section. I'm going to go over the homework. I'm not going to give you the answers. I'll give you some strategies right now. So we'll do that on the next slide. Okay, these two problems should be very simple. If you know that BD is the median of triangle ABC, you know that a median cuts the segment that it's going into in half. So if the segment that the median's drawn to is AC, and it's acting as a median, then I know these two pieces are equal, and you should be able to figure out what's missing for AD. Same situation for the next problem. BD is the median. If the median comes down and divides this segment in half, it means that each of those segments are equal. You should be able to find out the value for AD. Okay, the next ones with the graphs are more complicated. We'll do that next. Okay, for problems 3, 4, 5, and 6, you have a grid to look at right here, and you have two formulas, a distance formula and the midpoint formula. Okay, so it says find the coordinates of D, which is the midpoint of AB. So when I look for a midpoint formula, here it is. Here are the coordinates to B. Here are the coordinates for A. Okay, we have done midpoint formulas before. It just has been a little while. So if you want to find the midpoint of something, you average the x's, which would be 4 plus 8, which is 12. Divide them in half, and average the y's, which is 5 plus 1, which is 6 over 2. That should let you be able to get your midpoint. Okay, so get that midpoint. Okay, for number 4, find the length of the median CD. Now, it's not yet drawn in. So the first thing you want to do, I'm going to erase these marks. The first thing you want to do is draw the median so you can visualize where it is they're asking you to measure. So here comes my median, or at least a close approximation of it. So I'm going to come from this vertex out to my D, and there it is. That's my median. So they would like to know how long that is. Whenever you're asked how long something is, you're going to look at the distance formula and apply it to this problem. Now, you first need to write your coordinate pair in that you got from this midpoint formula. You have to write the coordinate pair for D. Then we're going to use the distance formula. Okay, the distance formula says you subtract the x's in order, so x2 minus x1, and then you square that. Then you add y2 minus y1 and square that. Then you take the square root of its sum. We have done this before, so I want you to practice doing it now and tell me how long this median is. Okay, for question 5, they ask us for the coordinates of E, which they're saying is the midpoint. So here's E right here. You need a midpoint. You are going to use the midpoint formula. Get coordinate pairs, because the very next question they ask you for the length of the median, and to get the length of the median you're going to use the distance formula. So again, let me try to put this in. If I'm starting here, oops, okay, try that again. If I start here and draw down to E, that's my median. They want to know that length. You use the distance formula. Okay, so I'm not doing the work for you, but I'm giving you a very good hint as to how to set it up. Okay, let's look at the next page of the homework. Okay, for questions 7 and 8, you first have to copy and complete the statement for triangle NP with those medians. So you're gonna replace the question mark with something else. Okay, so I'm going to eliminate. I'm going to eliminate the question mark. So you're gonna fill that in. But first you've got to draw this triangle. So if you have triangle MNP, so I should see a little triangle on your paper, and they tell you what the medians are. So if I have a dot here, and a dot here, and one here, and then I change colors and I draw in some medians from here to here. Okay, it's misbehaving. You know what you're doing, going from vertex to the midpoint, vertex to the midpoint, vertex to the midpoint. They will all come together in the center. They want to know QR equals what with respect to NR. Okay, so I believe since it's triangle MNP, where they come together, make this a little bit bigger, where these guys come together is going to be R, because that's a letter we have not explored, right? So figure this out by looking at your drawing and working it through. Okay, so now let's look at this last piece. S is the centroid. Remember what centroid means. It means it's where the medians come together. Okay, you need to know that. Okay, so they come together there. They give you some measurements. You should label your measurements. They give you RS as 4. They give you VW as 6. That's outside the triangle. They give you TV, that's the whole median strip, as 9. And they want you to find each of these. So you've got to go back and figure out the relationships. That 2/3 is a factor. The fact that a median divides a segment in half is going to help you. So go back, look at the notes, think through this homework, and we'll go over things in class.